eventually you need to pay fees for that pool depending on the amount of tokens, or anyone can like put more money in it and buy the pool for you. Why they will do that? Maybe a good proposal is coming. They want to win the proposal to get more staking rewards. I don't know. But well, if nobody want to buy it, the price is going to go lower, and then anyone can buy it as well. So that be it's a supply and demand market. So basically, eventually you have the borrower, which is the one that has the pool, and he is the one that gets the delegation, and he gets an NFT as well because it's nice to represent stuff in NFTs. All right, and then we have the Harvard tax mechanism, which is a blight. And then this is where we're gonna introduce the ZKP for the Halbeck taxes. So the auction house is gonna have a very classic ZKP auction mechanism that it kind of goes like you've got to lock your tokens beforehand. So this lock system is the same wallet I showed below, above. And then you have the commit phase. You have to place your hash commitment of your ZK proof with your amount. You submit that, we wait for the bid to review phase, we have a winner. The winner can submit to the vault that he can prove he wins. Then Harvard taxes will do everything. We'll delegate the property, the borrow will happen. And then we have the forfeit measure. So if the end of the review is over, we confiscate the funds of the said winner. Now it's not a winner anymore. And then we unlock everybody else's funds that participated in the auction. So this is the architecture. We're still looking technology. I don't know if we're gonna like build the ZK because there's a consensus protocol for anonymous auctions. They're actually pretty complete. So I don't know if I should like try something different or use something that already exists. And for the upper part here, for this upper guy here, so this pool technique here with lending and borrowing user accounts is already done. So right now it's just a matter of like implementing the Halberg taxes mechanism to keep drawing money from the pool and resetting pools and stuff, and also doing the blind auction. So right now everything is like centering around these and understanding more of like which tech we're gonna use to build that. All right, that's it. Any questions? Sorry, what?
Do you need external data for
No, but we're gonna need that. We're gonna need the circuits, of course, because we need to have we need to know who is the winner, so we can confiscate the funds. The rest is fully on chain. And also, like, we can also do like a public auction. Doesn't have to be private. Like, could be like could be a decision from the guy that lended the money to the pool. He could decide, I want this to be public, I want this to be private.
And you need one circuit per round of bidding?
Yeah.
Yeah, like one deployment of a verifying contract per round?
Yeah. I think only one circuit forever, actually. I'm gonna use the same. All right, thank you.
Sure. 当时那时候退休。
Hi everyone. My project is very simple. The project name is ZK Data Driven Social DApp. This project version team name. Remember that's me. Project name is this. Now I want to explain why I choose this project. I think the data privacy is very important. in our social apps. And I think ZKP can fit into this need. The first one, user can retain control over their data. The second one is content moderation and governance are decentralized and transparent. Second one is realize ZK core processor. It can make it ensures smooth and efficient ZK-based interactions. The last one is on-chain insights. On-chain data can be used to generate insights without sacrificing privacy. Next part is the aim to build a platform. I want to. The first one is data-driven architecture. Online. Online data utilization. It can collect user activities such as content publishing and voting, so it can enhance engagement. The second one is community moderation. Content moderation and governance are decentralized and transparent. The next one is ZKP efficiency. Otherwise, ZK core processor ensures smooth and efficient ZKP-based interactions. The last one is private insights. On-chain data can be used to generate insights without verifying privacy. The second part is core features and implementation. This part contains three sections. The first one is key functional features. The second one is development stack. The last one is example workflow for users. First, we can talk about the first one, key functional features. This section contains six parts. The first one is data-driven architecture. It contains online data utilization. The second one is decentralized operations. The second one is realize ZK core processor. This one contains voting function nice. Reputation system NFT management. The source is decentralized identity and user preferences. Data rejection and user preferences. The first is content creation, publishing, and storage. It contains editor interface, activity. The fifth is token rewards for engagement. It contains incentives that distribute. The last one is reaction interoperability. It contains cross-chain integration, future proof. The development state is the front will use React, CSS, and other technology to design the user layout. The backend will use Solidity to get the smart contrast, and I will use the Sequoia test that to test my project. I will use IPFS or other to store the content data. I will use the users and Web3 just to integration validate. The example workflow for users, user can registration. User can create and publish their content. They can also build community moderation. And that's why the content ownership and monetization. The source this part is talk about challenge and the solution. The first challenge is interoperability across backend. The solution is we can choose flexible adapters to use cross-chain compatibility tools. The second challenge is complexity of ZK logic implementation. The solution is various ZK core processor. And the third challenge is community moderation with anonymous voting. The solution is ZKPS various core processor. The last challenge is decentralized identity and governance. The solution is blockchain-based IT. This is the first challenge. The problem is integrating multiple blockchains is complex. We can choose one solution. And we can also earn the benefit adaptability to future Web3 innovations. This one the second challenge. The problem is ZKPS require intensive complications. So we can choose the various ZK processor offloads computations. The benefit is smooth and seamless interactions. The third challenge is community moderation with anonymous voting. This problem is ensuring fair content moderation without relying on centralized we can choose the solution is GCP as various processor. The method is bias-free, transparent content moderation. The last one kind is decentralized identity and governance. The problem is preventing fake accounts, and manipulation. We can choose the solution blockchain-based IPs. The benefits is transparent and fairness. The last part is conclusion. This project is aimed to ensure user privacy and ownership through NFTs and anonymous voting. The second one is enable trustless decentralized environment for social interactions. The last one is demonstrate how GPTs can reshape online privacy, paving the way for new Web3 possibility. Okay, thank you.
Oh, there's a microphone. Yes. How can we make this full screen? I have no idea. At this point.
เดี๋ยวฉันเปิดให้คำๆนะ All right. Shh. All right, guys. Thanks very much for having us today. We have Joy, we have Yo-Yo, and Jern. We are from Thailand and really blessed to be here. So, thanks for having us. Yeah, first of all, I think we want to ask some question for you guys. Why are you here? Why you guys join Invisible Garden? You love CK. Okay, what about you? Love CK. Okay. Yeah, and I think definitely some of you guys love CK. You want to learn more about CK, right? And I think we cannot deny that this is quite a good place, that we have a lot of mentors, we have a lot of people who really like to learn CK. But then like in Thailand, there's not a lot of education, or there's not a lot of resource for us to learn CK. In fact, so many of our Thai friends that you may see along the week, right? There's a lot of Thai comes and go because they had to do the work, they had to come back to school to study. They ask me a lot like, oh, is it really hard to find resource to learn CK? And we think to ourselves a lot that like, oh, maybe if it's a few years ago, it's maybe really hard, right? Because there's not a lot of resource, but now everything's on internet, there's a lot of MOOC. But what still makes it hard to learn CK, right? So we come up with a framework called like action and feedback. So it's pretty hard because even though you read books, you can't just like understand it so to a certain extent. You doesn't have a way to validate how you learned it. You don't have a way to do action. And even though you have action, like you ask to yourself, you ask whether this is right or wrong, there's no feedback to get back to you to really make sure you understand it correctly. So that's why we come up with our work. We call it CK Ninja. It is basically a framework for zero knowledge proof education. In fact, it is just a way to learn mathematics so that you can really like think like cryptographer and mathematician. So yeah, that's why we're here. We want to make sure that everyone can take an action to understand the material more, and not only just the action, we make sure you get feedback as well. I can, yeah, sure. All right, sure. So when we come up, right, so at first it looks like normal, like textbook, right? But again, we want to avoid it to look like textbook or even like watching stuff, right? So of course we will need to have some curriculum that we handcraft it, right? We have example, we have
We have definition and stuff, but what makes it really unique is that we integrate AI to make sure that you guys can give action and get feedback. There are so many types of questions. For example, right, once you read it, it is literally have a question called open-ended question that you can write a set that represents a square of integers. So yeah, if you want to give some live demo, because we haven't really prepared this. Yeah, okay, so if you give some BS answer, it's going to be wrong, right? But again, it's going to be like, be able to explain more and those stuff. So this is the first step of our like engineering, like breakthrough innovation. We make sure that our AI get resource from the curriculum that we write, and then it integrate it to the way that can ask to interact with people. And this is about set, right? So let's get to more like difficult like topics like group, right? Okay. So yeah, what is group? Blah 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 blah. They have some property. Of course, we have a normal things. This is single choice question. This is normal, right? Multiple choice as well, of course. Good job. Oh, okay. Yeah, notation. Yeah, again, this is. Can you explain something like what is closure property?
Yeah, we'll try something like not so good. Let's say closure is.
All right. It's a type. So yeah, again, this quiz come up after you learn material, right? So let's say, you write like closure is when you do stuff to a number and it's still in the same set, and then we have rating, we have like, so it's
okay, it's not perfect, and then it's gonna tell you like how you can be kind of more precise and so on. I think in general, right, we try to support like every level we want people to be able to take some kind of action. Like if you don't know anything, you just try something with it and it will try its best to kind of help you going forward. Like you can like, I don't know, and it will try to teach you. If you answer something not quite precise, it's like, okay guys, you somewhat understand, but okay, you can be more precise like this. And if you like, go take book example, it's probably gonna tell you that, okay, it's perfect, good job, and so on.
Just provide a way so that you can translate material from textbook
True,
into the way that you can interact with it directly, right?
Yep.
And we're not just in that. We also have the random question. What is it again?
So in this part, right, after you go through material and you want to like have more questions, we also ask AI to have generate more questions. You just can keep rolling more and more questions. This is like two good things about this. One is like you can learn a lot more, and it's also easier on the kind of like cost creator. Cause like one thing that we want to have in this is like, we want it to be easily maintained. Everything in the back end is like just a bunch of markdown, and everything else is like render kind of partly with AI, some is like with some markdown also. So it shouldn't be too hard for anyone to contribute to this course. So it's open source. Okay, we'll talk about it later. But
so the intuition again, right? It's just not like we don't want everyone who want to contribute need to like write their whole program. They can just like take a snippet of the textbook and put it there. They can write their own, and then we can use it as a tool to engage community as well, right? Let's say you learn a CK concept, and then you have your own curriculum. You write that. You can commit to this in the markdown format, and it's automatically like generate for you. You can write your own questions, which again implies from the curriculum, and the AI can help refine it and be the question like this, like open-ended for people to interact with your curriculum to really learn more. On active, again, action and feedback. We want to make sure we reinforce this cycle of learning.
nice.
But we have more as well. We have so many types of questions that we want to throw around and explore what makes learners learn the best. So again, this is many topics, right? Modulo, cyclic group, those stuff, and of course, like we want to make sure, right, that people think away. Like when you read books, right, you just like, oh, that makes sense, that makes sense, that makes sense, and then like so what, right? So we want to make sure that you can reinforce and really like, oh, modulo, why is it related to cryptography? What is cyclic group? Like why does it matter at all, right? And
and the last one is like, people usually say that like if you understand something, you should be able to teach it, or at least like explain it kind of simply to other people. So now we can have some AI that try to like in technical term pay dump and ask you stuff, and you get to teach it.
In this question, right, so let's say, hey, so we already finished how set group modulo stuff works. I'm pretty new to this stuff, can you teach me? So now you have to play a role of teacher to teach them. So I ask them, what do you want to know first? What is a set? Let's say, what is a set? You try to explain that, what is a set, right? So this is really active learning, right? You literally flip the position from answering the question to be the teacher who's teaching this donkey student. Alright, so
Range of
this
things.
is our learners teaching. Set is just some range of things we are talking about. So yeah, and then it can ask, right? Oh, okay, so like a list of things. What could that list be like? Even numbers, or does it number need to be bigger than that? It can give some weird answer, but it looks like curious student, right? And you need to solidify it to really reinforce your understanding.
Yeah. So yeah.
Yeah, something like this. Again, this is live. You go to ck.ninja now.
So
And yeah, you can take the course out.
Hey.
The repo is there. You can commit. You can. Can you show the GitHub?
So the repo is open source. Come and help us. We'll try our best to like keep the everything easy. So for you guys, just come in and book, right?
Yeah.
So actually, we should show this a bit.
Yeah.
Most of this content is just like simple markdown, and it will get kind of rendered by the engine. The fun bit is like I think
Yeah.
quiz.
Yes. So this is the chapter, right? Like
Okay.
each chapter we have their own corresponding quiz file. And so let's say this is chapter about group, right? So I write the curriculum about closure property, and then we have the quiz ID 1, right? That's the quiz ID 1. And then you go to the same name in the quiz folder. And yeah, here you can say that like ID, can you zoom in?
You still yeah.
So here we have like ID 1, right? And then you can have like, this is trivial, like choice. And then you can question for answer, correct answer, right? The more interesting one is about the open-ended one, right? That we use AI. So in the open-ended one, it can be really easy, like just kind and question. And then the answer that if you read from our curriculum, but it can be more complex, right? Can you show the context there?
Context อันเท่าไหร่ yeah
Oh, sorry, this one. Alright, yeah, this is the last one.
Okay.
So yeah, in this one, you open-ended as well, and then you can have context so that like just brief AI to be more like specific on
Yep.
the answer you want to get.
yeah come help us come help us ใส่เควสหน่อย
Okay, yeah.
Hi everyone, I am very happy to make a presentation here about our project POS. POS, what's the meaning of our project name is that Plankit 3 or Star. And our team composed with Jade, Dylan, Andrew, and me. And we also get some help from mentor like Ivan and Yu Guo. And we create this project this week, and we start working on it. So what's the so our major goal is that we want to integrate Stir into Plankit 3 to reduce the proof size, and we want to implement the verified circuit for the stack using Stir. So the first question is, what is Plankit 3? Plankit 3 is a popular stack repo, and it's very modular, and it is powered by Polygon. And the second question is, what is STIR? STIR stands for Shape to Improver Rate, and it's the new paper in this year about Reed-Solomon proximity testing, and it has been accepted by the Capital 2024. And the basic idea of STIR is that in Fry, the degree of the domain polynomial are reduced to 1 over k of the original size after folding. But in STIR, the degree of the polynomial is reduced to 1 over k of the original size, but the size of the domain is reduced to only a half of the original size after folding. So after folding, the code rate of STIR better than the code rate of Fry. So what's the meaning of better code rate here is that the code rate formula is here is rho equal to the d over the domain size, and the domain size here is n. So in Fry after folding, because you reduce the same size for your domain and polynomial, so the code rate after folding in Fry is equal to the original code rate. But instead, because